In this problem, we have a non-calculator problem, and this looks kind of like an AP free response one. Let's see if we can work through this, and it deals with a particle moving along the x-axis, and that at any time t is greater than or equal to 0, so we've got a restriction here, just keep that in mind. The acceleration is given by a of t is equal to 6t plus 6. At time t is equal to 0, it says here that the velocity of the particle is -9 and its position is -27. So if we think about that, v of 0 is going to be equal to -9, and let's just use p for our position function. P of 0 is actually going to be equal to -27. Our first part of this one, part A, says find the velocity of the particle at any time t. To do that, we need to find the antiderivative of a of t. So v of t will be equal to the integral or antiderivative of 6t plus 6 dt. So on the left-hand side, we have v of t. On the right-hand side, we'll write 3t squared. That's the antiderivative of 6t plus 6t, that's the antiderivative of 6, and of course, plus c. We'll use our given information that v at 0 is -9 to substitute that in and solve for c. So we have -9 is equal to c. 3 times 0 squared is 0. 6 times 0 is also 0. And we're going to go ahead and represent that then as v of t. And we're going to use the line when we first introduced that c, or right after we took the antiderivative. And that's going to be 3t squared plus 6t. And then, of course, our c value for that one is going to be -9. That's all this question is asking us to do. So that's our final answer for part C. If we move on to part B, it says for what value or values of t is greater than or equal to 0, another restriction here, same as before, is the particle moving to the right? Okay, so we need v of t to be greater than 0 or positive for the particle to be moving to the right. So we're going to take a look right here at 3t squared plus 6t minus 9. We're actually going to set that equal to 0. That's a possible change in sign from positive to negative or negative to positive. So that'll tell us some information that we need. And we've got 3t squared minus 6t minus 9. And that's actually going to be a positive 6t. That's going to help out a little bit. We're going to divide everything by 3 here, folks. So 0 divided by 3 is, well, still 0. We will wind up with t squared plus 2t then minus 3. That'll just ease your pain a little bit as you try to find the 0 for this particular one. So we've got 0 is equal to, and we're going to factor this one. So we need two numbers that multiply to be -3, but add to be 2. So that's positive 3 and -1. Setting each one of these factors equal to 0, we find t to be -3 or 1. Now, -3 is not going to work for us because that doesn't fit our restriction on t here. So when we draw a number line, we're going to make our number line start right here at 0, and then we'll have 1. And we're going to use the expression for the derivative to figure out what sign the derivative has, let's say between 0 and 1. So we'll make t equal to 1/2. We'll test that point right there. So if we look at this line, we've got, let's see, 3.5 times 1/2 minus 1 is -1/2. So that's going to be a negative value. So anything between 0 and 1, the value of the velocity, let me go ahead and write that on the number line, that's what we're looking at here, is going to be negative. Let's pick anything to the right of 1, like when t is equal to 2. So if we think about that, then our velocity will be, it's actually going to be 3 times this. I should put the 3 out front. Well, we're just worried about the sign here. And when t is equal to 2, we'll have 3 times 5. That's t plus 3. And then 2 minus 1 is 1. So whatever that is, that's going to be positive. So we'll put a positive sign here. So anything to the right of 1, the velocity is going to be positive. Well, to list this as our response, it says the question, let's go back and read the question. It says for what value or values of t is greater than or equal to 0 is the particle moving to the right. So we can just use the question to help us write the response. So we could say the particle is moving to the right for, let's see, 1 to infinity, or when t is over that interval, 1 to infinity, because v of t is greater than 0. Or you can say v of t is positive, meaning that the particle is moving to the right. Moving on to part C, it says find the net distance traveled by the particle over the interval 0 to 2. So the net distance is the same as displacement here. So for our net distance, what we're going to do is we're going to take the absolute value of, and we're going to do, let's see here, we'll do p of 2 minus p of 0. So that'll be the change in position from p of 2 to p of 0. Now we actually haven't defined p yet, so let's say let p of t equal the position of the particle. And we actually have to figure that out first before we can actually do this. So we're going to go back up to where we found that velocity function, which was this one right here, 3t squared plus 6t minus 9. And we're going to have to take the antiderivative of that one. So we'll take the antiderivative of 3t squared plus 6t minus 9 and dt. Let me just verify that I haven't made a mistake on this one. And we look to be good to go. So let's see here. P of t is going to be equal to, and I'll write then t to the third power, that's the antiderivative of 3t squared, plus, and then the next part I'm going to have is going to be 3, whoops, that ran together a little bit. So we're going to do plus now 3t squared, that's the antiderivative of 6t, minus 9t plus c. And we got to see if we got any information about any position for this guy right here. So it looks like we're going to use this one here. P at 0 is equal to negative 27. So we're going to go back down. We've got negative 27 here, and that's P of 0. So the t value is 0 for that one. And you probably don't even have to write down all those terms because all those terms are going to be equal to 0. So our initial value is negative 27 here. So we're actually going to have P of t being equal to t to the third plus 3t squared minus 9t and then minus 27. We're going to have to figure out a couple things here. This is what we're actually trying to find, which is our net distance. So what we need to figure out is P at 2. So let's see if we can figure out what P at 2 is. I think we already know what P at 0 is. So 2 to the third is 8. And then 3 times 2 squared is the same as 3 times 4, which is 12. And then we've got, let's see, negative 9 times 2, which is negative 18 minus 27. So let's see, what's this all going to work out to be? That's 8 and 12 is 20, minus 18 is 2, minus 27 is negative 25. So we'll come up here and we'll do negative 25, and then we have to do minus P at 0. Remember, P at 0 was negative 27. So we're already given that information. We don't have to do any work there. And what we're going to do then is we're going to take the absolute value of negative 25 minus negative 27, which happens to be 2. And the absolute value of 2 is just 2. So there's your net distance for this particular problem. Part D says find the total distance traveled by the particle over the interval 0 to 2. And the total distance here is going to be a little different because there's a change in direction, or the particle changes directions over that interval. So if we want the total distance, we're going to have to break this up into 2 net distances. So this will be P at 2 minus P at 1, and we're using P at 1 because when t is equal to 1 is when that particle, when the velocity is changing right up here, right here at 1, the velocity is changing from negative to positive, so the particle is going from moving to the left to then changing directions and moving to the right again when exactly t is equal to 1. So we also want to break this up, and we want to add P of 1 then minus P of 0. So what you're essentially doing is you're saying, well, I want the distance in one direction, and we're going to add that to the distance in the other direction. So we've got a few of these already. P at 2, let's see, I think we said that was negative 25. Yep, we did that before. You don't have to do that again. We're going to need to figure out this one right here. So we'll figure that out in a second. And that's going to go here as well. Plus, P at 0 we said was negative 27. So we got to figure out what P at 1 is for this one. So we'll use our expression for that, which is t to the third plus 3t squared. So that'll be 3 times 1 squared, or 1 to the third, excuse me. Oh boy. And that is not the expression for P of t. Let's go back up here. So P at t is t to the third first, which is 1. And then if we look up here, we've got 3 times 1 squared. So there's your plus 3. And then if we continue to go on here, we've got minus 9 times 1, which is negative 9, and then minus 27. So that'll be 4 minus 9, which is negative 5, minus 27 is negative 32. So that's kind of some side work here. And then we'll replace that with P at 1, which is negative 32 here, and then negative 32 here. So negative 25 minus negative 32 happens to be positive 7. And we then need negative 32. And that should be a minus sign here. Made another whoopsie there. Sorry for the mistakes on this one. Should be the difference between the positions. How silly of me. So that'll be negative 32 minus negative 27, which happens to be negative 5. And if we put the absolute value of 7, which is 7, together with the absolute value of negative 5, which is 5, we wind up with 12 for our total distance here.